All right. Welcome to today's lecture. This is essentially the opening to fat metabolism. And what we're going to talk about is how does your body adapt to caloric restriction? So what you're looking at here, this is a graph by Anderson and colleagues. What you're looking at is initial weight loss. And then you see you have anywhere ranging from 6 kilograms to 17 kilograms of weight loss. That's year one. And then what you see is how much of that weight loss remained over 2 years, over 3 years, over 4 years, over 5 years. One thing we know is that over 1/3 of lost weight tends to return within the first year. And as you can see here, the majority is gained back within 3 to 5 years. So your body doesn't like to sustain weight loss. In fact, we see that right here. In this study here, they took obese individuals and they had them lose about 10% of their body weight. Then you look at basically that took 19 weeks. You look around 52 weeks later, and half that weight was gained back. And 175 weeks, it was all gained back. So it suggests that weight loss is not very sustainable. Well, why? We have this concept known as the energy gap. And basically, the energy gap means that when we diet, our metabolic rate goes down, but our appetite goes up. And so, increased appetite, decreased metabolic rate, that's a perfect recipe to regain weight. So to really go into the energy gap a little bit here, what I want you to look here is look at graph B, look at figure B, and what you have is EI is energy expenditure, energy intake, and TEE is total energy expended. Okay, so if you look when they're normal weight, like obese, that's how many kilocalories per day. If you look when you reduce their weight, okay, notice that you can see here, actually the second arrow here, when you reduce weight, obviously energy intake decreases, but total energy expenditure decreases as well. And then if you look at the arrow next to day one, what you're seeing is that when you refeed these individuals, let them eat ad libitum, obviously their energy intake goes up. In fact, it goes up above baseline. And yet their metabolism stays suppressed. So if you were to look here at this graph, this is energy balance when they were weight reduced, so they were in a negative calorie balance. But then when they said, okay, eat ad libitum, you can see there that their energy balance was positive. In fact, it was more positive than it was negative originally. So again, we see weight reduced after the caloric restriction, but by day 14, half of that weight, or more than half, is recovered. So this just clearly shows this energy gap. So why do we have energy gap? Well, a couple of reasons. One are adipose signals. Two are central adaptations. Three, declines in energy expenditure. Four, change in metabolic rate. And then five, change in the function of the liver, fat cells, and muscle cells. Let's talk about adipose signals. Two critical signals for adipose are leptin and insulin. Okay, both leptin and insulin drastically lower when you're calorically restricted, and when they're low, it signals that nutrient availability is lowered. And why does leptin lower? Leptin lowers because fat cells shrink, and insulin lowers because fat cells become very sensitive to insulin signaling. Okay, and you can see that here. If we look at over here in graph A, when you reduce energy intake, insulin goes down. Then you look at graph B, When you reduce energy intake, regardless if it's 12, 25, or 40% fat, insulin levels go down. And leptin levels go down. However, when you refeed, basically insulin levels will go back up as well as leptin levels. However, it does take time to completely relapse. And then if you look, that's the main things I actually want you to look at. Next thing is also one thing to understand is that muscle tissue decreases beta oxidation. So the rate that you're utilizing fatty acids is decreased with dieting, and the liver increases capacity for de novo triglyceride synthesis. So this is bad news, right? One thing to know about adipose is that when it decreases in size, it increases in insulin sensitivity. So that means that basal levels, meaning when you're fasted, basal levels of lipolysis will be lower because you're more sensitive to that amount of insulin that's there. When you do consume food, you have increased impact of insulin's effects on fatty acid synthesis, so that will go up. And so you all, in general, have an increased gene expression for fat synthesis, causing you to go back the other way. As far as metabolic efficiency, we see decreased thyroid hormones and catecholamines, along with a decline in mitochondrial leak channels. You also have lower organ mass and lower food consumed. All of these result in lower metabolic rate. So here we're looking at metabolic efficiency. You see when people are normally obese, when you reduce their weight, their metabolic efficiency goes up by 25%. They start to conserve more energy. And after refeeding, it's still elevated by day 14. So again, a decrease in metabolic hormones like thyroid hormones, catecholamines, a decrease in mitochondrial leak channels, which we also call uncoupling channels, or proteins, lower organ mass. So if you weighed your liver, it would weigh less, lower food consumed. Satiety signals change. POMC, or pro-opiomelanocortin. Pro-opiomelanocortin is one of the main things that decrease hunger and appetite, and neuropeptide Y increases hunger. So if you look here, when you are in a calorie-restricted state, neuropeptide Y goes up, meaning you're hungrier. POMC goes down, so you don't have the same decrease in hunger. And also, we think that you may decrease the sensitivity to satiety signals, like insulin and leptin, for example. What does this result in? Elevated appetite. So in summary, when you're losing weight, an energy gap is created, in which energy expenditure declines, metabolic efficiency and appetite increases. This results from decreased leptin and insulin secretion, increased MPY and decreased POMC, decreased body mass, organ mass, and lean mass, decreased catecholamine-induced thermogenesis, and decreased thyroid hormone output. What does this mean? Any weight loss strategy that fails to acknowledge and plan for these emerging metabolic adaptations is likely to have little success in facilitating long-term weight reduction. To ensure success, the regain prevention strategies will likely need to be just as comprehensive, persistent, and redundant as the biological adaptations they are attempting to counter. Thanks, and I'll see you next time.